All right, so here we go. So let's, you know how I always like to tie things together. So let's kind of look back. So we, this is from chapter 13, but this year we kind of did it all together. So the big idea was we thought about these outputs for terms and sequences, and we wanted to look as the sequence got more and more terms. And then we talked about this. You read this as n approaches infinity. We picked n because the inputs to a sequence rule are natural numbers, and we were thinking about the end behavior. And we talked about a couple different sequences, but this is a rational function, and we knew that at the end, this function behaved like the ratio of its leading terms, and we would say that eventually we think the terms got really close to 1. And that's from chapter 13. Okay, and then we got a little bit more advanced because that's why we're here, right? Okay, and so instead of just thinking about inputs being natural numbers, we thought about x. So x is any real number, and this just becomes like a function. Okay, so let's look at the places we're looking at. Just like with the sequences, we can think about the end behavior, so the input can go to infinity. But because now we're looking at functions, the input could also go the other way. It could go to negative infinity. So this would be at the right end, this would be at the left end. Okay, and you could pick any number you want. So let's just pick 2. That's a nice number to think about the function at. And nothing crazy happens there. And let's pick something where that's something that's kind of interesting. So I want to pick 12. Why did I pick 12? Because if you put a 12 in there, you're dividing by 0. Okay, so let's think about these limits. Get a pen. Okay, so for these two, sort of the same thinking. Since the function f is a rational function, we can know that its ends, its model is pretty close to this ratio, but this ratio is 1. So we say these two limits are 1. And then, since we're thinking about functions, not sequences, let's think about a particular value. So a real number is the input. Well, if you put in 2, nothing crazy happens. And this is really what happens most of the time. For most values of x, the function behaves nicely. So if you just put a 2 in, you get 2 squared plus 1. You will get, what do we get? 2 minus 12 squared, and I think that's 5 over 100. So the limit is just the same as the output. So nice, not too interesting. Versus if you put a 12 in. Well, if you try to put a 12 in, you'll get 144 plus 1. You could put a 12 in from any direction. So this is going to get super close to 0. Maybe it's a little bigger than 0. Maybe it's a little smaller than 0. But when you square that, you're going to get 145 over 0 that's a positive number. We talked about that's going to go up to plus infinity. Okay, so let's kind of talk about the basic, what is super helpful for me, and your book doesn't talk about it, is when I'm trying to look at the limit, I may do some algebra, but sometimes I'm thinking about these base cases. Okay, so this is a Miss Brady word, this base cases. I've never seen this word, but this is how I think about it. Here's something I know because of my arithmetic skills. If you have some number k, and essentially you're dividing by either, say it's like 7 over infinity, or it's 7 over negative infinity, or it's negative 12 over infinity, or negative 12 over negative infinity. No matter which way it sort of comes, these are getting to be super, super, super close to 0. And we know that if we have a limit in this form, that's going to 0. Okay? So that one I know by thinking about it. Okay, now if I do this one, let's kind of pick some examples. So k is a number. Let's do 7 again. And this time, though, because we're not actually evaluating it 0, you have to get really close. You're either going to come from the right or the left. So what if you're 0 from the plus? Well, this is a plus number because a plus number divided by a plus number gives you a plus number. But maybe your constant was like negative 12. and maybe you're coming at 0 from the left, and both these would be positive numbers. And because you're dividing by 0, we know it's going to explode. So this goes to plus infinity. Okay, and you can sort of think about the other way too. What if you do 0, but you're coming at a 0 from the left? You have a plus number over a negative number, that's negative. You could do negative 12 over a little tiny positive decimal. And in both cases, these numbers are negative. And so for this form, you got two choices. You know that the outputs are going to explode, but you have to do a little investigation to find out, are they going to explode up or are they going to explode down? And you have to decide. Okay. The third case is, what if you're looking where you're adding two things and the first part's getting infinitely big and the second part's getting infinitely big? Well, you're like, Miss Brady, no duh, that's going to have to be infinitely big. You could also do like negative infinity plus a negative infinity, but usually you see this first one. Okay, so those are, to me, are like the ones you can use your number sense, and your number sense is going to be right. Okay, here's ones, and I didn't make this up. These are called indeterminate forms. Okay, and really, I like a good name. I like to call these, you need more investigation. Just by writing down these ratios, you don't know what's really going to happen. Okay, so the three ratios to know are, let me grab a different pen. Okay, if you have these three ratios, if you have something that's getting infinitely big over something that's infinitely big, if you have, the way in math we say that, we say infinity over infinity, you say 0 over 0. If you have something that's infinitely big minus something that's infinitely big, and you can change them a little, like this would be the same as like minus infinity over minus infinity, and this would be like minus infinity plus infinity. Those are all the same things, but those are indeterminate. We have to do something extra to figure them out. And some skills we're going to learn this unit, some skills you need to wait till you get to calculus. Okay, I'll make an example for this one, why this is indeterminate. Okay, let me put a couple examples. What if I had, looking at a ratio of like x squared plus x over x cubed plus x. Okay, that's a rational function. This is going to go, and it's getting big and big. Okay, if you're having that input, say x is going to infinity for all these. So that's still an infinity over infinity, but this one's going to go to 0. Versus if you had the reverse, then it will go to plus infinity. Okay, or you can even get a number, like if you have 2x squared plus x over x squared plus 7x, that's actually going to go to 2. So you don't know. You have to do more investigation. You can't just look at this ratio and know. So here are the three that are indeterminate. If you have an infinite over an infinity, if you have a 0 over 0, or if you are subtracting infinities. Versus if you have a number over infinities, you can decide that's going to 0. A number over something that's going to 0, you got to think about it a little bit because you got two choices. And if you're adding infinities, that's going to infinity.